Welcome. We will look at the application of Monte Carlo estimation simulation for cost estimation. Uh, so it's the same learning objective as it for the previous video, except that for this video you will be able to actually do it, like or you have not actually do it, but have a you'll be actually be able to do, because I will provide for you the Python code. So if you know, even without knowing how to use Python, it's very simple. Like you can just change your problem, like you can tailor your code for your problem. But in the third video, I will show you how to do this with Excel, so you will know how to actually like do it. Yeah, if you know how to use Excel. Okay, but it's more like the same objective as the previous thing. So here we will apply this to a problem, and I selected a very simple problem because again, the objective here is not to estimate the cost for an actual project. That's not the objective, but the objective is that you have this conceptual understanding, like what is Monte Carlo, which is like random sampling, what is the probability distribution, which basically tell you the likelihood of possible outcome, or like the frequency or likelihood of possible outcome. What is and then how to run like as a Monte Carlo simulation and produce like your uh, probability density function, and then cumulative probability distribution. So that's basically the idea here. So let's look at the simple problem. So you have like, we aim to estimate the profit uncertainty. So how much are we gonna make? Like, are we gonna make $1 million, or are we gonna make $100,000, or are we gonna maybe lose? Yeah. In 5 year for a 10-acre mango farm. I mean, why mango farm? I don't know. Maybe because I like to eat mango. Where the planting plan fixes the number of tree at 1,000. So in 5 year, we would expect that we will have 1,000 tree. This number is not uncertain. This number we consider it certain. Like we don't. Uh, Maybe we will consider plant will not die, or will keep them in a good condition. So by 5 year, we will have about, in this 10 acre, we will have 100,000 tree. And in 5 year, again, whether these numbers are real or not, these are all made up numbers. So just for, so I don't know like how many trees would be in 1 acre of a mango farm. So according to this estimate, it's like 100 tree. I don't know if this is realistic or no, but again, don't look at these costs, like just look at the steps. Like, so the revenue is calculated from uncertainty of annual yield per tree and sale price per pound. So these are my two biggest uncertainty, like how much each tree will yield, because that could depend on different factors like climatic condition, like the temperature, precipitation. It could also due to other factor uh, like pest control, and how effective is my pest control programs, or and my how well I maintain my farm, and so on and so forth. Yeah, so that is how much the fertilizers, like how effective is my fertilizers and fertilization plan, and where I be able to get like some new and innovative and like fertilizers that will help to increase or improve my yield. Yeah, so that is yield per tree. Okay. And sale price per pound, that is depend on supply demand, and it depend on the general economic situation. So in 5 years from now, I'm that's like another big uncertainty. So these one, I model them with a triangular and beta distribution respectively. Like, why did I select triangular and beta distribution? Mainly because I want to show you these two distribution and how to use them. Yeah. Uh, the operating cost. So now this is with respect to my revenue. I have two uncertain items. With respect to my operating cost, I have a lot of them. The labor costs, the irrigation costs, the fertilization costs, the maintenance costs, the marketing costs, and insurance are also uncertain, and I model this using various distributions just to show you like a mixture of distributions that can be used. By performing Monte Carlo simulation, we isolate the effect of yield, price, and cost uncertainty on profit while the tree count remain constant. So this is deterministic. So I want to show you this is deterministic, this is uncertain, and all these guys are uncertain. So here, what I just showed you is the first step, like identify key cost driver. So these are, in that case, not cost, like profit driver. So the key profit driver are yield per tree and sales price per pound. This with respect to the revenue. Uh, because profit is revenue minus cost. That's like how you operate, calculate your revenue. Like your profit is revenue minus operating cost. And then these are my, so I have uh, how many key cost driver in that example. So in that example, I have one, or profit drivers. I have one, two, three, four, five, six, seven, eight. I have eight of them. Yeah. And then you select a distribution for each. So for example, for the annual yield per tree, I selected a triangular distribution. For the sales price per pound, I selected a beta distribution. For these guys, I selected various distribution, which I will show you later. And then you just draw a sample and you calculate the cost. And then you do like your frequency, like you plot like the histogram for your of your different sample and calculate the frequency of occurrence of each cost like pin here. And then you can, this last step, which just this is just a reminder, is like to do cumulative probability, and you can see what is the probability, for example, that I will make a profit above or below my baseline profit. Baseline profit, that's like your normal profit, or like or what you are planning for. Yeah. Okay, so here this is the table that I will use to make like my Python code or my Excel sheet for when I use the software. So yield per tree, I use the triangular distribution. Bounded distribution with clear mean, mode, and maximum reflect expected yield range. So here, this is my expected yield range. And again, I don't know if each tree will give you uh, this number of pounds or not. These are just all made up. Yeah. So again, like it is not like like this number might not be realistic, but the method is, that's the most important part. So each tree is expected to give you about 300 to 400 to 500 pound. Yeah. The price per pound, that is like beta scale. So it is naturally bound with flexibility to capture the skewness in market price. So I have like this my alpha, this is my beta, this is my minimum. So my minimum, I'm expecting I will not sell this mango per pound for less than 75 cents. My maximum, if everything is favorable and I was able maybe to market it well or whatever, and I got like good yield and there's high demand and good marketing strategies, then I could get to like 2.5. Yeah. The number of trees, that is deterministic. It's like fixed planting plan, and that's like about 1,000. Yeah. So the labor I will use for this normal and clipped. So this is based on historic data suggests systematic variation around the mean. Clipping prevent unrealistic negatives or unrealistics in general. But it is generally like when we do clipping, we could also uh, like present also unrealistic negative. But here it's not just unrealistic negatives, but here just unrealistic values in general. So here, for example, in this 10 acre, I'm expecting to the annual cost would be like hire one label. This labor might cost me around $75,000 plus or minus like $5,000. This labor will no way take less than $50,000, and this labor will no way also takes than $95,000. Irrigation, I will use like a triangular fertilizer and pest control. Uh, here I have like clear uncertainty because I know like my mean, I know my max, I know my mood maintenance. So now I use like triangle bounded course with central tendency again, and then like uniform. So no strong central tendency or value within the range are equally likely. Reflects uncertain expenses with equal likely for any the value of range. So basically that is a description of these distributions that I'm using. So here, triangular, beta, normal, clipped, triangular, uniform. So I can show you this distribution. So for my yield, it is 400 per tree. That's my most likely. It could be 300, could be 500. See, this is the beta with alpha is equal to 2 and beta is equal to 1.5. So you see something that looks like this, which is skewed more to the right, which means that I'm more optimistic. I'm more on the optimistic side. I know that I could sell this mango as low as 75 cent, but I'm more on the I know I could sell it as high as $2.5, but I'm more on the optimistic side. I'm expecting most probably to sell it around $1.7 per pound. Yeah, so I'm more on the optimistic side rather than the pessimistic side. Uh, Here for the normal distribution, and it is clipped around like this value. Okay, so this is my labor is here. It could be plus or 5,000 or more. Like this is my irrigation. It's more skewed to the left, so I'm also more optimistic here is that I could save on my irrigation costs if I have favorable like weather condition. The fertilizer is like equal probability, so I could be here, could be here, could go to the left or go to the right. With respect to the maintenance, I'm more on the optimistic side that I could save some on the maintenance cost. With respect to marketing cost, that could be uh, I don't know like whether I will be from here to here, and insurance I don't know whether I'll be here or here. So all these uh, uh, are equally likely. Okay, so basically I can just calculate my baseline cost. So my baseline cost, like this is like per yield per tree, like so the triangular. I can assume like my baseline is 400 uh, uh, pounds per tree. Price per pound, like if I did this scale beta, you get like about like a nominal cost or like an average cost of 1.92. And then the number of trees 1000. So you multiply the number of pounds you get by the price of each pound by the number of trees, then you get like your revenue. So about like 760 or $770,000. Now with the labor cost, that's my mean value for the irrigations. That's my mean value or my expected value here. For this guys, that's my expected value, my expected value, my expected value. So the cost would be like the summation of all these guys. Yeah. And then if I subtracted my revenue from my cost, I get my profit. Yeah. And now here I'm showing you like how I calculated this mean value for a beta distribution if you're curious. This is a deterministic estimate. So my deterministic estimate is telling me what? It's telling me I will make around 600K of profit. That's what my deterministic estimate is telling me. I'll make about 600K of profit. But what would my Monte Carlo estimate tell me about this 600? Giving like these uncertainties that I have, like giving this uncertainty, and all these uncertainty. What does Monte Carlo tell me? So here again, I would run Monte Carlo like thousands of times, and then after you run it thousands of times, I think I ran here like 10,000 times. This is use the simulated profit distribution for year 5. So this is at year 5. This is the simulated profit distribution. So what do I have here? So the minimum is around here, about like 100. Like this is in the million. So this is in a scale of a million. So the minimum is here, which you can see about like $80,000. That's like about here, $80,000. That's the minimum profit that I will make. The maximum profit, I could go above 1 million. So again, this is in K, like 5 year in K. So this is like 80,000. This is 1060, so that's like 1 million. So here the maximum profit is here. But usually we don't look at the minimum and the maximum because this could be even outliers and non-realistic. So we just look at the typically we look at the credible interval, or like the 80-95% like a credible interval. And in that case, like my 90, so basically my credible interval is that like I look at my 90, like, so I take my sample and I just keep like 95% of the sample. I remove like the extreme sample, like, so I remove like all the sample like here. So I remove like this sample, oops, which like constitute like 2.5%. And like I remove like this sample like 2.5%. And like from here to here, that would be my 95% credible interval. So, so my 95% credible intervals, like I just remove like this sample because this could be like some, uh, and I remove this sample. So if I remove this sample, like like the profit I could make either 200,000 or I could make as much as 870,000. That's for my 95% like credible interval. What is my mean value, or like the one that is in the mean? Yeah. So my mean value is about 530 plus or minus one, like this is one standard deviation 180. So if you assume that this like follow a normal distribution, you calculated like the mean value for this normal distribution and like plus one or plus or minus like one standard deviation, then you get like the mean value around here. So the mean value is a little bit less than my baseline, my deterministic estimate. The median value is similar to the mean value. So basically that is what we learned from this estimate. So from this estimate, we didn't only like get one value, which is like a baseline 600, but you get a mean with the standard deviation. So the mean is like what I'm expected to win, or what's likely to happen, is about 530 plus or minus 180. That's basically your estimate. What would be the range for profit? So the profit could range from 200 to about 870. That is like my range for profit with like 95% credible interval. The mean, this is the mean as a maximum, but with like 95% credible intervals, that would be my range. Now, what is the probability? So now here you can, the last thing you can do like cumulative probability distribution. So here, like the cumulative probability distribution, that is here, and this has like, so at this like nominal cost, which we calculated here, like the $602 or whatever, the probability is about like 63%. So what does this mean? That there is about uh, uh, 63% probability, or you can look at like let's say this is like 63% probability, or that you could look at it like 70, yeah, 37 probability. So basically there are 37% probability that my profit will not exceed this 600. That is basically like how you interpret this. So there are about 37% probability that my profit will not exceed this 600. Yeah. So there are about 63% probability that my profit will be below this like deterministic estimate. There is about 63% probability that my profit will be below. And we see here the mean is like 530. Here again, what is the probability that that my project will like, I'll make like 1 million? Yeah, it's almost zero. That I will exceed 1 million. It's almost zero. Yeah. So there's a zero probability that I will exceed 1 million. Now here, what is the probability? Remember this number was like 80,000. What is the probability that my profit will be above 80,000 K? There is a 100% probability that my profit will be about 80,000 K. But there are 0% probabilities that my profit will be above like, what is this number? Above like 1.06 million. There's 0% probabilities that I will exceed this profit. Yeah. Now, one more thing you can do, like this is in step 6, is like you can do like this tornado chart. So basically in this tornado chart, like you have 8 different items. You see which one drive your cost more. So like that is also something you can do. You can see which of these item drives my cost more on control, more my cost. And obviously in that, like if you even look at here, like see this is much higher, like your revenue is much higher than your profit. So it would be like these two guys, like that really drive your cost more or like your profit more. And you can see here this is on like the low side of these guys, and this is on the high side of this guy, like the price and the lead. So it's basically the price, that's the main controlling factor. So the main controlling factor is the price, which depend on like the market and like economic condition, and the yield, which mainly like depend big part on the climate and like other like pests, and how like you can manage like these two. And the rest, like the label and like your cost item is not like the big variable. Like your big variable is like the price and the yield. But again, remember, all these are fictitious prices. This has by no mean any recommendation on Mango Farm, or these numbers are realistic for Mango Farm. Just this is just like an example to help you to understand the concepts. But if you want to make like a feasibility study by a mango farm, you have to uh, consult, like you have to get like actual information, but you can use this the same process. So let me show you like the code, like for the Python code for this. So the Python code for this is, so I have it here. Make this like a full screen maybe. So this is the Python code, like you can read here about your problem. This is the table that I just showed you, and this is the details of each distribution. So here, this will just like plot like this distribution for you. And this code here, that's where basically you can input each of this distribution. And here you see like I provided, like you can pause the video and read this, like I provided you information on alpha and beta value, and like how the different alpha and beta value will change the shape of your distribution. And I already showed you like a figure with this. And you can play with this value here, because see, like you can plot this code here, so you can play with different alpha and beta value and see like how the distribution will change shape. Same with all these guys. You can play like with these values. So the beta distribution, for example, is, where is this? Yeah, here, alpha and beta. So you can change like your alpha and beta values, and like 2 and like 1.5, and then you will get different you can get different shapes for this one. And here I provided more information for you. See, this is the minimum price, the maximum price, the alpha, the beta. This is how you do Monte Carlo. So you use like NumPy. So NumPy, you do like random, and then you select the distribution beta, and you pass these variable alpha, beta parameter, and whatever other numerical the number of simulation, which is in that case like 10,000. Yeah, you pass the, like how many samples do I need, like the number of simulation. Yeah, and then you can calculate the price per sample. Okay, and then this is the number of three. You can calculate your revenue, basically like your yield time price per sample time the number of three. Similarly, here for your cost item, so the labor, it has like a mean, that's the standard deviation. Again, you use NumPy, random, you select the normal distribution, you pass the number of your parameter here, so the mean and the standard deviation and the number of simulation, and then here like numpy clip, I want to clip these samples to this range, so the clip the sample to a realistic range. And then here for the irrigation, I use a triangular distribution. You can change this by your item. Yeah. So, and the reason I'm giving you a diversity of them like beta distribution, alpha, uniform distribution, triangular distribution, normal distribution, and with clipping, so that you can, if you want to tailor this code for your purpose, you can tailor this code for your purpose. Yeah. And how to run this code, basically, like if you want to control enter, and I will show you when we get to the running, and then basically the path is just like for plotting this figure. So here, see, this is the mean profit, the median profit, the standard deviation, the minimum profit, the maximum profit, and the credible interval. So this is just one run. If I want to, remember, this is random. So if I did this again, like this number will change. But if I am using so many sample, like 10,000 sample, like they will not change much. Versus if I'm only using 100 sample, we can do this experiment now. So let's just run this again. So to run this code, you go like control enter. So if you run control enter, see it is taking time, partly because my computer is slow, but another part because it's like drawing thousands of sample. But you see here, I got something that looks very similar. So like you see, these numbers are very similar. These numbers are very similar. Here, this was 200,000. Now it's 200,001. It's very similar. Let me run it again one more time. So let's look at this one. So this is our maximum profit, for example. Or like, let's look here. Minimum profit 108. When we run it again, let's see what would be the new value. So when we run it again, it's like 107. Versus if I reduce the number of Monte Carlo sample, like the number of realizations, each time you will run it, you will get a different answer because it will not be accurate. So let me, where is this number? It's not here. Sorry, it's here. So let me just reduce this like, so to just 100 sample, yeah, instead of just 100 sample. So if we run this with 100 sample, it will not be accurate, yeah. Let's see how accurate it will be. So if you run this with like 100 sample, see, that's only 100 sample. See, the minimum profit is like 200. It was 80 or like, it was like 100 and whatever. See, like the mean value is not accurate. See, like this guy is not accurate because you don't get any distributions that looks like anything. You only have like the frequency of this guy is only for the freak because you didn't build like, you didn't sample your space, like your probability space sufficiently. Let's do it with 1000 sample. So with 1000 sample, uh, see, like you get something. Now you started to be real. Like, see, the mean profit is very close to what we have before, the minimum profit and maximum profit. You're credible and like started to be a little bit close. But now, if we run it with like 10,000 sample, for example, then that would be the, like here, you see, is that's where you get to this one. And like the variation, like if I run it again, I will get something similar. Versus if it's 1000 sample and I run it again, I will get, each time I will get a new answer. Let me show you. Like if I'm running this with 1000 sample, yeah. So this is 1000 sample. Okay. I will, each time you'll get a new answer because your variability is high. Like your Monte Carlo didn't converge and your variability is high. So like you see here, I got like 1,000,008 as my maximum profits. Then I run it again and I got like 1,000,004. I mean, it's not bad. Like it converged, but it's not bad. Like the variability is not bad, but it's not perfect also. Uh, like if I run it again, like 970. See, like that's very variable. Like so, the variability is very bad because you don't have enough sample. And I I provided an example for you here. Like if you want to look at the conversion of Monte Carlo sampling, I mean, you can read this example. I didn't present this because I didn't want to confuse you, but here what I want to show you, like I'm trying to estimate the value of pi, like pi of a circle, pi r square, and see this is the number of samples. So if I have few number of sample, like see my number, the value of pi is off. If I have many number of samples, see I'm approaching the true value. Yeah, 3.1 there. Yeah, 3.14. Yeah, so I'm approaching like uh, the true value. So basically, that is the impact of the number of sampling on the conversion of your thing. And then like here you can see like you can do this like a tornado chart, which will tell you the how like the impact of the price on the total cost. Like so here that would be the most pessimistic scenario you can, and that would be the most optimistic case. Yeah. And you can look here at this value. So okay, this is all for this video. And next video I will show you like how to repeat this exercise with Excel, because if you are not familiar with Python and you want to use this, I will show you how to repeat this with Excel. It's an optional video, you don't need to watch it, yeah, unless you want to.